Incorrect measurements by our flow measurement systems can have many causes. In addition to a technical defect of the measuring unit, an incorrect measurement can also be a result of the overall process or the design of the system. To be able to reliably verify the cause of the error, the first step is to create a service report. Using this report, our application engineers in the factory can define the cause of the error with an accuracy rate of almost 100%. The service report covers the recording of the situation on site, as well as test reports for the sensor and electronics. By creating these logs, we form a reliable basis to provide our customers with the best advice and guarantee the reliability of the system in its processes. Once you have worked through this course, you will know how to perform the optical inspection on site and what factors are important, what operating conditions have to be checked and logged for a service assignment, how the service interface is set up and operated, how to check the electronics and sensors, and how to edit and fill out the service log. For optimal operation of the measuring systems, certain structural prerequisites are vitally important to ensure that the flow meters can operate reliably. These must be checked on site and documented for a subsequent check in the factory. Together with the measuring logs, this allows a reliable recommendation to be issued for rectifying the problem. Firstly, take a photograph of the measuring unit. The important items here are the measuring system, the inlet and outlet section, and the electronics. Before taking the photos, consult the plant operator and request permission to take the photos. You should receive permission if you explain to the plant operator why you want to take the photos and what they will be used for. The following chapter explains which pictures are required. The inlet and outlet sections from and to the flow meter are important. Why? I will explain this briefly. When measuring the flow, it is important that the liquid flows through the measuring system evenly. A pipe bend changes the flow profile of the medium. Because of inertia, the liquid flows out of the rear bend outlet faster than from the front area. This can lead to the flow meter measuring results showing values that are too high or too low. Gates, controllers, and other obstacles can also negatively influence the flow profile of the medium as a result of turbulence. Therefore, it is important that after an elbow or any other obstacle, the medium can homogenize sufficiently. To allow this, a straight area must be reserved on the measuring unit in accordance with the specifications or the data sheet, with at least 5 or 10 times the nominal diameter of the flow meter in the inlet area and at least 2 or 3 times the nominal diameter in the outlet area. The nominal diameter, dN, of the flow meter is noted on the nameplate. For the factor table, see the data sheet. The mounting position of the flow meter is also important. Because of the unfavorable flow profile caused by the angle, the two measuring electrodes record different values. As the flow meter has been correctly attached, both electrodes are positioned in the central area, which means that the measuring errors can be largely compensated for even in unfavorable system installations. The flow profile is particularly problematic if a round elbow is used in the inlet or outlet area, as here the medium is particularly heavily influenced by the double deflection. It is especially important here to observe the required straight inlet and outlet sections in accordance with the specifications in the data sheet. As the earth is the central reference point for inductive flow measurement, in the next step, check that the earthing is correctly wired and document this with photos. Firstly, the medium must of course be earthed via the pipe connection. It is important here that the pipe has direct contact with the medium and that there are no insulating layers in the pipe. If the piping has no conductive contact with the medium, appropriate earthing screws for an image should be used. A poor or non-existent earth and/or an empty meter tube leads to an incorrect measured value and/or no measured value at all. The flow meter must be earthed at the screw connection provided. The electronics must also be earthed at the earthing screw. All earthing lines must be connected to a central building earth. Ideally, the inductive flow meter should be installed in a vertical mounting position. Any gas bubbles present in the medium then rise directly upward, ensuring that the EMF is always correctly filled. In a horizontal mounting position, gases may collect in the upper part of the pipe. In particular, if the EMF electrodes are located in this part, implausible measuring results are obtained. Therefore, the vertical position is ideal for the device. If a horizontal installation is necessary, appropriate equipment must be provided to ensure that the piping is always filled with liquid. Of course, the minimum distances as described previously in the Inlet and Outlet Sections chapter must be taken into account. The last visual check is of the electrical lines from the flow meter system to the remote transmitter. Please also document this check with meaningful photos. First, check the shielding of the connection cable. This must be extensively connected to and around the cable clip so it can absorb high-frequency interference signals. The connection leads should be kept as short as possible, particularly the electrode leads. With regard to the electrode leads, it is particularly important that the core of the connection leads is not damaged and that no short circuits arise as a result of the fine wires of the shielding, which may be sticking out, as shown in this example. All cables must be firmly inserted in the cable shoes as well as being firmly clamped at the terminals. The same applies to the connections in the sensor. Here too, the shielding of the connection cable must be largely in contact with the cable relief, the connection leads must be short, no cores may be damaged, the shielding of the electrode leads must not cause any short circuits, and all leads must lie securely on the terminals. The circuit diagram for checking that the wiring is correct can be found in the flow meter manual. When you are called to a service assignment, you should first speak to the customer, as he can provide important information about the problem. Please summarize the result of the conversation in the service log. The following questions are particularly important. Was the measuring point commissioned from new? Have the problems existed from the beginning, or did they only occur later? If the problems did not occur until later, this can have various causes. Therefore, questions that clarify what changes could have led to a problem are important. For example, whether the medium was changed, whether the temperatures of the medium have changed, or whether changes were made to the wiring, or the system, or application. All measures and changes by the customer should be documented in the service log. If piping is not completely filled, the transmitter can display incorrect values. As soon as the electrodes have no contact with the medium, and therefore no contact with the reference earth, which is a forbidden state, zero flow may be indicated, or unrealistically high measured values displayed. If piping can run empty in the application, a detector can be activated in the transmitter. For a description, see the operating manual for the transmitter. However, it is not only empty pipes or gas formation in the pipe that lead to incorrect measuring results. The electrodes are in continuous contact with the medium to be measured. This can lead to the formation of deposits on the electrodes. Deposits in the device and on and between the sensors and electrodes can lead to malfunctions and incorrect measurements. A conductive deposit that establishes an electrical connection between the medium and the electrode leads to an incorrect measurement. A lower flow is indicated. An insulating deposit also leads to an incorrect measurement. Here, however, a higher flow is indicated. Therefore, it is recommended that after a certain time and in the event of an unanticipated deviation in the measured values, the device and the electrodes be cleaned. If the electrodes are excessively dirty or cleaning no longer appears to be useful, the sensor or the measuring unit should be replaced. Once the visual check has been completed and all questions about the operating conditions have been clarified, the next step is to read out the parameters and the flow meter alarm log. For the communication between the electronics and your computer, you need an infrared adapter. This can be ordered from the ABB spare parts service. The infrared adapter is placed on the electronics flush with the display. To relieve the strain, the cable of the infrared adapter can be placed between the PG glands of the electronics housing. Insert the connector of the infrared adapter in a USB port on the notebook. Now start the service port splitter program supplied with the infrared adapter. The aim is to perform a parameter dump and an alarm dump. However, to be able to read out all of the parameters of the control unit, you must first enter the service password. To do this, you have to start the ABB Remote HMI program. You can download this via the Internet. The display of the HMI shows a replica of the real control unit. The operation is equivalent to the operation on the device keyboard. To enter the service code, click the right-hand button on the virtual control unit once to call up the menu. Then, using the down arrow button, go to the service item and confirm again with the right-hand button. You can now enter the service code and confirm again with the right-hand button. All service functions are now released. First, you must perform a fingerprint. To do this, call up the Diagnosis menu, then the Fingerprint function, and then Manual Fingerprint. Now enter and save the current system parameters, such as the coil resistance and the signal input linearity. This enables a comparison with the values at the time of the fingerprint at any time, for example, to reset the values to the initial values in the event of changes. In the next step, you can perform a parameter dump. In this process, all of the current settings for the transmitter are transferred to the computer. This gives you access to the settings that you found when you started your service assignment at any time. For the communication with the electronics, you need a terminal program. Hyperterminal is a component of Windows XP distribution. If you do not have access to this component, you can obtain the program from Hillgrave, or alternatively, you can use the open source software Yukon. The settings must be made accordingly. We will show you the subsequent procedure using the Hyperterminal program. If you need help setting up the terminal program, call up the complete procedure to start the service connector tutorial. Once you have established the connection to the control unit in your terminal program, you can perform the parameter dump. To do this, in the menu of the terminal program, select the Transfer tab and then Text Transfer. Assign a unique name for the file. This should contain the customer and the serial number of the device so that the data can be assigned in the factory later if necessary. Now start the transfer by confirming in the terminal program and then press the C button to start the parameter dump. The data is now transferred from the control unit and written to the file, and appears on the screen of the terminal program. The dump finishes when there is no further data to be transferred. Once you have performed the parameter dump, save the stored alarm message from the flow meter. Start the alarm dump with the I button. Again, the data stored in the control unit is transferred and written to the same file as in the previous parameter dump. As soon as the data has been backed up, in the menu of the terminal program, call up the Transfer tab and select the item Text Transfer. End the saved operation there. In the process log, previously selected measured values from the transmitter are recorded in cycles and thus can be evaluated at a later point in time, e.g. with Microsoft Excel, and displayed graphically. This log and the measuring data recorded are particularly helpful for problems that occur occasionally. To check the transmitter, you need a flow meter sensor simulator. It is executed and saved in the same way as the parameter dump, with the only difference being that a different communications port is used. To check the transmitter, you need a flow meter sensor simulator. You can order this from the ABB spare parts service. The flow meter sensor simulator generates all of the signals of a sensor. You can use it to simulate and check the current inputs and outputs, as well as the pulse inputs and outputs. This allows you to check that the transmitter is working correctly. To check the electronics, it is important that you disconnect them from the power supply. To do this, remove the device's fuse on the left-hand side. Caution! You must remove this fuse, as the second fuse in the middle of the transmitter is only the fuse for the sensor. Once you have disconnected the electronics from the power supply, undo the 4 screws on the housing and remove the housing cover. Undo the 3 screws on the flow meter sensor. These are secured and cannot fall out. Once you have undone the 3 screws, carefully take the flow meter sensor module out. When taking the flow meter sensor module out, make sure that you grip the entire housing. The cover of the flow meter sensor can also be undone. If you only take the cover out, the connection cable may be damaged if handled incorrectly. Before placing the transmitter on the flow meter sensor simulator, check the contact pins on the rear of the transmitter. These can be bent if not inserted carefully. If a contact pin is bent, important connections to the sensor or power supply are missing. This may mean that you have already found the error. Now use the flow meter sensor simulator to test the transmitter. To do this, place the flow meter sensor on the simulator. Make sure that you do not bend any contact pins. Screw the flow meter sensor on tightly with the 3 screws. Now switch the simulator on. Once the simulator has been switched on and the check starts, the flow meter sensor asks what has been replaced. Answer this question with transmitter. All specific system data of the transmitter is uploaded from the memory board of the simulator. No transmitter data or sensor data is deleted or changed. Only the measuring point area data is checked. Once you have checked the electronics of the flow meter sensor, you must check the sensor. We need the coil resistances, the insulation resistances, and the electrode impedance. To perform the measurement, you need an adapter plate, referred to as an XE board. You can order this from the ABB spare parts service. To do this, remove the sensor PCB and disconnect the PCB connectors, the 3-pin electrode connector, and the 2-pin coil connector at the rear. Proceed with caution and make sure that you do not damage the connectors. Now insert both connectors in the female connectors on the XE board. This board has the advantage that the connector contacts are run on large terminals, which makes measuring the following steps easier. First, measure the resistance of the coil. To do this, you need a resistance measuring device. Measure the coil resistance on the right-hand smaller terminal between the M1 and M2 contacts and enter the measured value in the measuring log. You can check whether the measured value is correct by looking at the defined reference value for the coil resistance of the default fingerprint. To do this, in the menu call up the diagnosis function, then fingerprint, and then default fingerprint. All of the values of the default fingerprint are stored here. If the coil resistance value is correct, measure the coil insulation. You can do this with the coil installed and with the meter tube full. To do this, connect the earth of the insulation measuring device to the sensor housing. Measure the insulation of the coil with a voltage of 500 volts. Caution: high voltage. Proceed with extreme caution in the following steps. Now measure the insulation resistance of the coil at contacts M1 and M2 of the smaller connector on the XE board. If the coil insulation is OK, the insulation measuring device display must not move at all. If movement is visible, this indicates a faulty coil insulation to earth. Enter the measured values in the measuring log. The electrode impedance is measured with the LCR. To do this, set the LCR meter to impedance measurement at a frequency of 120 Hz. First, measure between contacts 1 and 3 of the wider connector on the XE board for the impedance of electrode 1, and then between contacts 2 and 3 for the impedance of electrode 2. Then measure directly between contacts 1 and 2 for the impedance between the electrodes. Perform the measurement again with a frequency of 1 kHz and enter all values in the measuring log. Enter all of the information from the customer conversation, the measured values of the control unit, the coils, and the electrodes in the measuring log, and send the log with the photos and the transferred data to the factory for further processing. You can open the measuring log as a PDF document via the Measuring Log button. If you have not already done so, reinsert the electronics of the flow meter sensor in the control unit and screw the unit closed with the 3 screws. When inserting the flow meter sensor, make sure that you do not bend any of the pins on the connector strips. Now delete the alarm history in the transmitter. You do this in the Process Alarm menu. On completion of the work, perform a further parameter dump. You have already learned how to do this in an earlier chapter of the tutorial. This allows you to check and compare any parameters that have changed during the service assignment. Check the cabling again, reinsert the control unit fuse, and screw the control unit closed. Finally, reinsert the sensor PCB. To do this, carefully reattach the connectors of the coil and electrodes. Insert the PCB and screw it down. Close the sensor housing.